Hello everyone, myself Mr. Awais Ahmad Hussaini, working as Assistant Professor in Mechanical Engineering Department at Sharad Institute of Technology, College of Engineering, Yadrao. In this lecture, we are going to discuss about some fundamentals about the fluid mechanics, and we are going to focus on the losses in the pipe fittings. So as we know that the concept that is flow through pipes, in that the basic fundamental things related with the Bernoulli's equation and continuity equation. Just we go through first these two equations and then we will move further. So as we know that the Bernoulli's equation is related with the incompressible and inviscous fluid, in that the total mechanical energy, in that there are summation of the three energies like pressure energy, kinetic energy and potential energy remains constant throughout the streamline flow. So this is the Bernoulli's equation, Bernoulli's principle. It will helpful for us to study that further, the flow through pipes concept. Also we are aware about the continuity equation. In continuity equation, it works on the basic principle of the conservation of the mass, and it states that the mass flow rate of the fluid in a pipe is constant along the pipe throughout the length. So this is the main continuity equation. So according to the continuity equation, we know that the Q is equal to A into V. Suppose there is one pipe, if we consider the inlet and outlet section, then the equation becomes A1 V1 is equal to A2 V2 is equal to Q. So it will helpful for us to solve the numericals related with the flow through the pipes. Also we are aware about some kind of the Reynolds number. There is one experiment in which we are going to study the Reynolds number of the water. So according to the number, we can determine the type of the fluid. If the Reynolds number is less than 2000, it is supposed to be laminar. If it is in between 2000 to 4000, it is transient. If it is more than 4000, then we can assume it as a turbulent flow. So this is the basic things regarding the fluid flow and flow through the pipes. But the major question is regarding how that and why that particular flow through pipes is important. So the main basic thing related with the pipe flow or the water flow is the losses. So the more important or major important point related with the flow through pipes are the losses. In that we are going to discuss the two losses, that is, one is major loss and second one is a minor loss. So in case of the major loss, it occurs because of the friction. Okay, if the water or if any kind of the fluid is flowing through the pipe, then definitely the friction takes place in between that surface of the tube or pipe or that particular fluid which is flowing throughout this particular pipe. So this loss is supposed to be major loss, and we never eliminate 100% this loss, but we can minimize it by providing some change using the standard materials and surface finish to that inner section of the pipe. And we can determine or we can find or evaluate this major loss by two equations. One is Darcy equation and second one is Chase's equation. And the minor losses are the losses which we can be avoid. We can minimize it, but we never minimize, but not minimize, but we never eliminate the major losses. But we can eliminate, we can 100% minimize the minor losses. And these losses are occurs because of the so many things. Like suppose there is one pipe and the pipe are having the different sections like series pipe, then the loss which occurs because of the sudden expansion, the loss which is occurs because of the sudden contraction, then entry loss, exit loss, or if any obstacle is present inside the tube or pipe, then this loss is nothing but the minor loss. Then if the pipe are having n number of the bends, then elbow, this particular loss is supposed to be minor loss. Also leakage losses are also treated as a minor losses. Okay, so here we are study that first of all the major losses. So the basic formula to calculate the major losses is one, that is Darcy-Weisbach equation. The formula is 4FLV square upon 2GD. So in that D is the diameter of that particular pipe, V is the velocity, G is the standard gravity, that is its value is 9.81 meter per second square. Then L is the length of that particular pipe, and F is the frictional factor, and we can calculate it by consideration of that Reynolds number as well. And the second equation is Chase's equation. The basic formula to calculate the major loss under the Chase's is V is equal to C under root of the Mi. Okay, where V is the velocity, C is the Chase's constant, and we can calculate that I by HF upon L, and we can calculate that Chase's constant C is equal to under root of density into gravity upon that frictional factor. So these are the different methods through which we can calculate the major loss. One is Darcy equation, second one is a Chase's equation. So through this particular figure we are going to discuss the minor losses. So here you will get, in first figure you will get idea about the entry and exit loss. Suppose there is one pipe which are having entry and exit sections, so whatever the loss occurs, it is nothing but the minor loss. In second figure they mention the sudden expansion. If the cross sectional area of the pipe is continuously increasing or suddenly increasing, then this particular loss is treated as a expansion loss or enlargement loss. If the pipe which is having some constant cross sectional area and that pipe section goes on reduces suddenly, then this particular loss is come under contraction loss. If the pipe are having, or the tube is having n number of the bends and elbow, then this particular loss occurs of the particular fluid is nothing but that bend loss and elbow loss. Okay, so this is the basic formula to calculate the various minor losses. If we consider the loss of head at the entrance, the formula is HE, H stand for that loss, is equal to K is a factor of that particular loss. Then the formula is HE is equal to Ke into V square upon 2G, where V is the velocity of the fluid which is passing through this particular pipe. Then second is loss of head at submerged discharge, or you can say it as a discharge into the still water. Then the formula is HD is equal to KD into V square upon 2G, where you must have to consider the value of the KD is equal to 1. If the pipe are having sudden contraction, then the formula becomes HC is equal to, HC stand for loss of head due to contraction, is equal to KC is the factor or loss by related with the contraction, that is KC, into V square upon 2G, where V stand for the velocity. Then if we consider the loss due to expansion, the formula becomes V1 minus V2 square upon 2G. Here we have to consider the velocity of the two section. If the expansion is there, then one section are having is small and other section is large, so the diameter of the each pipe is different in that section, so definitely velocity get affected. So here we will get answer with the help of this particular formula. Then the next one is a loss in the pipe fittings. It can be calculated by using formula HP is equal to K into V square upon 2G. If the loss occurs due to elbow or bend, the formula is remains same, that is KB into V square upon 2G. So by overall consideration of this particular all formula, you will get the velocity is important factor, and we will get velocity by diameter of the pipe. So the elbow diameter is different, then regular pipe diameter is different, where the cross sectional area goes suddenly change, like expansion and contraction, where the diameter is again change. So definitely the velocity is going to change, and we can calculate the losses in this way. Okay, so after that, the most important point of this particular flow through pipes is different pipes which are available in the fluid flow. So here we are going to discuss the 4 different types of the pipe. In figure number 1, here we will get idea about the series pipe. So what exactly the series pipe? Series pipes is a configuration where multiple pipes are connected end to end, and the fluid flows sequentially through each pipe. Okay, first fluid is passing through this particular first pipe, then second pipe, then third pipe, then it will move towards B. So here we will get idea about the minor and major losses also. If we consider this pipe, And if we talk about the major and minor losses, then major losses occurs because of the friction only, and there are three types. Three different pipes are used having different cross sectional. Definitely these are circular pipe, but the length as well as diameter is different. So the major losses we will get in three places. Again, here entry loss is there, then contraction loss is there, enlargement loss is there, exit loss is there. So these all losses are covered as a, or it can be treated as a minor loss. Okay, so what are the different applications of the series pipe? So the series pipes are generally used when the total head loss need to be distributed across the multiple section of the pipe system. They are often seen in the hydraulic system where different components require specific flow rate and the pressure level. So for that purpose that series pipes are used. And when we talk about the parallel pipe, so in case of the parallel pipe is refers to such kind of the configuration where multiple pipes, here there are total 3 pipes are there, and minimum 2 to 3 pipes is the requirement of the parallel pipe. These all different pipes, all 4 pipes are having the same length. Diameter might be changed, but the length should be same, so it is called as a parallel pipe. Okay, and this particular section or this particular pipes are generally used in such a place where distribution of the network or cooling system or industrial process application, and the total discharge is calculated by calculating the discharge of the each and every pipe. If we add the discharge of the Q1, Q2 and Q3, we will get the Q. But when we talk about the major loss in 3 pipe, it should be same. So we can write HL1 is equal to HL2 is equal to HL3, means major loss in all 3 pipes are same because the material is same, the length is same. And when we talk about the equivalent pipe, so equivalent pipe is a continuous pipe which is continuously long pipe without any contraction, enlargement, and you can say it as a convergent section. Okay, so equivalent pipes used in the simplicity or in where the complex geometry is not available or not necessary, and the application of this particular pipe is for allowing the engineers to model and simulate the behavior of the entire system efficiently. For that purpose we can use the equivalent pipe. Okay, so the equivalent pipe diameter and the length are calculated based on the flow rate, pressure drop and characteristics of that particular individual pipe. And when we talk about the siphon pipe is generally a U-shaped pipe, and it allows the fluid to flow uphill from one reservoir to another reservoir. It can be generally preferred for various applications such as drainage water from one container to another, and transferring the liquid between different level and creating the vacuum pressure in the system. So this is the important different types of the pipes in the fluid flow. So guys, here we are studied the different major losses, minor losses and different pipes. So again, the last point of our discussion is experiment which is related with the major and minor losses. While conducting the major and minor losses, here we must have one experimental setup of it includes some kind of the bend section. So here if the section is here, then it is a bend section, so it can be treated as a minor loss. Then again the straight pipeline is there, so it can be treated as a major frictional loss. Then after that the sudden expansion is there, so enlargement is there. So here the pressure difference we are getting, and with the help of that pressure difference we can calculate the discharge and velocity, and with the help of some standard formula we will get the answer. Again the water is continuously flowing through the straight pipe. Here again major loss is come under picture. After that here the cross sectional area goes change, and here the pipe section goes on reduces. So again the minor loss like contraction loss is there, and with the help of some standard formula we will get that particular answer of that how much contraction loss is there. Again some kind of the bend is there. So it consists of one electrical motor along with the pump, and one bypass pipeline and suction pipe, and this is the arrangement, and this is a reservoir. This is the main reservoir, and this is some tank where we are going to calculate the volume by stopping the valve. So it will helpful for us to calculate the major and minor losses. Thank you.